Hi, and welcome to my series on A Guide to Completing the CXC Mathematics SBA. Part 5 of this series will focus on the data analysis. In this section, marks will be awarded for the adherence to approaches previously stated and finding a mathematical solution to the problem stated in the objective. The term adherence is used to mean the establishment of a clear relationship between the type of analysis done and the data collected. This as the researcher seeks to have his research question answered. Specifically, it includes the clear establishment of your analytical assumption. For example, if the mean represented the average math score obtained by a student A at the end of the term, things affecting the mean can include the switch from face-to-face modality to online or student A moving to another school. The researcher needs to acknowledge these factors or state that they are not considered for the purpose of his or her SBA. Only established analytical formula must be used in your analysis. This does not mean that you cannot derive a formula. For example, recently I derived a formula for calculating the volume of a log for a hardware store owner, using only the circumference of the log and the height. Analytical diagrams must be appropriate for the type of analysis done. For example, if you wanted to establish the mode from a continuous dataset, your diagram should be either a histogram or a cumulative frequency curve. And finally, diagrams must be clearly labeled to get a clearer picture of your analysis. A statistical solution to the problem mostly involves descriptive analysis. This comprises of four main descriptors, namely measures of position, measures of central tendencies, measures of dispersion, and measures of frequencies. Measures of position include quartiles, deciles, interquartile ranges, and percentiles. Measures of central tendency include the mean, median, and mode. Measures of dispersion include the range, semi-interquartile range, standard deviation, and variance. Finally, measures of frequency involve count, percent, and frequency. We will discuss non-statistical problems a little later. To obtain full marks for this section, explanations must be clear and sufficient. This means that you need to explain the meaning of the symbols used in your calculations. For example, if you use this formula, then you must explain what SIQR, Q3, and Q1 means. Additionally, marks are awarded for accurate application of theorem or formulae. This means that you must ensure that accurate mathematical principles are used to derive your solution. This is particularly useful for non-statistical studies. For example, if you were given this house and you were required to estimate the amount of roofing material needed to cover one side of the roof, then you may need to obtain the slanted side using a trigonometrical method. Then you will use the length and the breadth to obtain the area. Then divide this area by the area occupied by one of the roofing sheets. Finally, there must be a provision for about 10% of additional sheeting material to cover the amount for wastage and overlapping. It is also important that you ensure that all your calculations are error-free. This can be verified by your teacher. For example, for a statistical SBA, show how you arrived at the measures used in the descriptive analysis. checking your answer to ensure accuracy. Remember, there is no need to show calculations for standard deviation and variance. You can simply use Excel to do these calculations. Here is an example. If you were investigating whether a new fertilizer boosts plant growth over a 30-day period, you may need to display two cumulative frequency curves and calculate the semi-interquartile ranges. Here is how this can be calculated. Note that your solution must clearly state the answer and it must be easily identified. Let us now look at the section B. This section deals with the application of mathematical solutions to real-world problem your SBA seeks to address. Here, you can use similar studies with similar analytical approaches as a point of reference. Let us look at some real-world application of the calculated values in this section. To do this, we will use the same plant growth SBA that we spoke about previously. One summary data you can use is the mean. Contextually, this data gives the average daily plant growth throughout the 30-day period. Quartiles may also be used to observe portions of the data. For example, the lower quartile represents the lowest 25% of daily plant growth of the data collected. The interquartile range may also be used to see how widely spread is the middle 50% of the plant growth. This is the formula used for calculating the interquartile range. The semi-interquartile range is also an excellent substitute for the standard deviation, especially if the data is skewed. That is, if most of the plant growth data is low with a few high ones or vice versa. As mentioned before, this is the formula used for calculating the semi-interquartile range. You should note that the smaller the interquartile range, the closer each data point is to the mean. This means that the number representing the mean plant growth is more reliable since it is a better representation of the data points. This is the end of the video. Thanks for watching. Please don't forget to like, share, and subscribe. Let's move this mathematics forward.